Okay, we're continuing to work more example problems that involve the use of the sum and difference identities for sine and tangent. Okay, so let's get started. And actually, this problem looks like we can use the sum identity for cosine. Not sure why exactly they're giving us cosine functions in this section, but okay, so here's the sum identity for cosine, so we can expand this as cosine 30 cosine theta minus sine 30 sine theta. And then in the previous video, we had drawn the reference triangles. So the reference 30, 60, 90, and 45, 45, 90 triangle. So cosine of 30 is root 3 over 2. And sine 30 is 1/2. And there we go. So cosine of 30 plus theta is equal to root 3 over 2 cosine theta minus 1/2 sine theta. All right, what about cosine 60 plus theta? So another cosine for some reason. So that's cosine of 60 cosine theta minus sine 60 sine theta. Okay, cosine 60 is 1/2. Sine 60 is root 3 over 2. And there we go. All right, and now another cosine. So this should be the last cosine, but we've got, so okay, 3 pi over 4. Well, let's expand this out, actually. So the difference formula for cosine, that's going to be cosine 3 pi over 4 cosine x plus sine 3 pi over 4 sine x. Okay, now what is 3 pi over 4 in degrees? So multiply this by 180 over pi. So 180 divided by 4 is 45. 45 times 3 is 135. So this is 3 pi over 4 is 135. And so 135 is in the second quadrant with reference angle 45. So cosine of 135 would be minus 1 over root 2. And then sine would be 1 over root 2. Now we can rationalize this. Multiply by root 2 over root 2. That's going to be root 2 over 2. So we can do, let's say, root 2 over 2 and then put sine x first minus root 2 over 2 cosine x. Okay, so now we have a tangent. Let's use the sum formula for tangent to expand this out. So tangent of theta plus 30 is equal to tangent of theta plus tangent of 30 over 1 minus tangent of theta tangent of 30. Okay, tangent of 30, we can see opposite over adjacent, 1 over root 3. One minus and then 1 over root 3 tangent theta. So let's see. Let's multiply this by 1 in the form of root 3 over root 3. So that's going to be root 3 tangent theta plus 1 over 1 minus, or no, root 3 minus tangent theta. Okay, there we go. Okay, let's expand this out using the sum formula for sine. So, okay, sine pi over 4 cosine x plus cosine pi over 4 sine x. All right, now what is pi over 4 in degrees? That's 45 degrees. All right, so sine of 45 degrees, that's going to be 1 over root 2. Okay, cosine of 45, that's also going to be 1 over root 2. So we can write this as root 2 over 2 sine x plus cosine x. Okay, so here we can use just once again the difference formula for sine. So we'll have sine of 270 cosine theta minus cosine 270 sine theta. All right, now what is 270? Let's see, 180 plus 90 is 270. So that's this angle. All right, so sine of that angle, let's see, that would be the y is, so that's -1, that's sine of 270, and then cosine of 270 is 0. So this is minus cosine theta. Okay. Tangent 2 pi minus x, use the difference formula for tangent. So we've got tangent 2 pi minus tangent x over 1 plus tangent 2 pi tangent x. Okay, what is tangent of 2 pi? That's, you're here. That theta is equal to 0. So that tangent of at 0, that's 0. So minus tangent x over 1. So it's just tangent of 2 pi minus x is minus tangent x. Okay, tangent pi minus x. Let's use the difference formula for tangent. So tangent a minus b, okay, we've got tangent of pi minus tangent of x over 1 plus tangent of pi tangent of x. Okay, tangent of pi, that's this angle here. So again, y is 0 here, so tangent of pi is 0. So we've got minus tangent of x over 1. So tangent of pi minus x is equal to minus tangent x. Okay. For these problems, we want to use the given information here to find sine of s plus t, tangent of s plus t, and the quadrant of s plus t. All right, so we worked problems like this in the previous section with the sum and difference formulas for cosine. But what we're going to do here is we could use the exact same procedure that we did with those problems, which was based on, like, we could construct a triangle based on the given information using the general definition for trig functions, and then kind of figure out what the missing side was and then get the rest of the trig functions we needed. But we're going to go another route where you'll see. Okay, so, all right. To get sine of s plus t and tangent of s plus t, we're going to need tangent of s, tangent of t, sine of s, sine of t, and cosine of s and cosine of t. Right? If you think about those formulas, they're going to involve sine of s plus t. When you expand it out, is going to have sine of s and cosine of s, and sine of t and cosine of t. Right? And then tangent of s plus t, when you expand it out, it's going to have tangent of s and tangent of t. So we need all of those trig functions. Well, we've got cosine of s and sine of t. So how can let's start by getting cosine of t and sine of s. Well, we can do that with the Pythagorean identity that relates sine and cosine. So we know that sine squared s plus cosine squared s is going to be equal to 1, right? Well, we know cosine squared s, that's going to be 3/5 squared. So sine squared s plus 9 over 25 is equal to 1. So sine squared s is equal to 1, which we can write as 25 over 25 minus 9 over 25. So sine squared s is equal to 16 over 25. So now let's take the square root of both sides. We need to apply the square root property. So sine of s is equal to plus or minus 4/5. So it could be either one of these. However, it gives us the quadrant of s. S is in quadrant 1. So all trig functions, no matter what the trig function, in quadrant 1 is going to be positive. So since s is in quadrant 1, we know that sine of s must be equal to 4/5. So there we go. We'll write that. Sine of s is equal to 4/5. Okay, now we can do the same thing to get cosine of t. All right, so sine squared of t, that's 5/13 squared. All right, so 25 over 169. Okay, so cosine squared is equal to 169 over 169. So cosine squared of t is 169 minus 25 is 144 over 169. Take the square root of both sides. So plus or minus 12 over 13. Okay, but t is in quadrant 1, so this is positive. Okay, but now we need tangent of s and tangent of t. How can we get that? Well, we know that, so tangent of s is going to be, based on the quotient property, is sine of s over cosine of s. Sine of s is 4/5 divided by cosine of s, take the reciprocal. So there we go. Tangent of s is equal to 4/3. So now what about tangent of t? That's sine of t over cosine of t. So sine of t is 5/13. Cosine of t is 5/12. Okay. So what is sine of s plus t? We'll use the sum formula for sine. So that's going to be sine of s cosine of t plus cosine of s sine of t. So sine of s is 4/5, cosine of t 12/13, cosine of s 3/5, sine of t 5/13. So let's see, we've got 48 over 65 plus 3 over 13. So 48 over 65 plus 63 over 65. There you go. That is sine of s plus t. Now, tangent of s plus t, we've got tangent of a, so that's tangent of s, 4/3, plus tangent of b, that's going to be 5/12, over 1 minus tangent of a times tangent of b. So, okay, 4 over 4 times, let's see, that's 16 over 12 plus 5 over 12. Okay, then 1 minus 5/9, so it's 9 over 9 minus 5/9. Okay, so let's see, 21 over 12 times, okay, 12 divided by 3 is 4, so 63 over 16. All right, tangent of s plus t is 63 over 16. Okay, so same type of problem. Let's get, so sine squared s plus cosine squared s is equal to 1. Now we've got cosine squared s is going to be minus 8/17 squared, so it's going to be 64 over 289. Okay, so sine squared s is 289 over 289 minus 64 over 289. So 289 minus 64 is 225. Okay. So square root of 225 is 15. Okay, now S and T are in quadrant 3, and so we know that sine in quadrant 3 is negative. So sine S is minus 15 over 17. Okay. Sine squared t plus cosine squared t. All right, 9 over 25. That's minus 3/5 squared. So 25 minus 9, that's 16. So, okay. Sine is negative in quadrant 3. So There we go. Okay, so now tangent S is sine S over cosine S. So that's going to be minus 15 over 17 times, and then minus 17 over 18. So minus 15 over 18. 15 divided by 3 is 5. 18 divided by 3 is 6. So minus 5/6. Okay, now tangent of t is sine t over cosine t. So minus 4/5 times the reciprocal of cosine t. So minus, that's 4/3. So tangent t is 4/3. Okay. So sine of s plus t is, so sine of s cosine of t plus cosine of s sine of t. Sine of s times cosine of t plus cosine of s times sine of t. Okay, so 15 divided by 5 is 3. All right, so let's see, that would be 9 over 17 and then plus 32 over 85. So $77 over 85. So sine of s plus t is 77 over 85. Okay, now tangent s plus t, I think I made a mistake here. Let's redo. So, okay, tangent s is sine s over cosine s, so minus 15/17 times, and then minus 17 over 8. So that's going to be 15 over 8. Okay. All right, now sine t over cosine t, 4/5 times minus 5/3. And that's right, 4/3. So, okay. I had messed up tangent s. All right. So tangent s plus t is equal to tangent s plus tangent t over 1 minus tangent s tangent t. So, okay, tangent s plus tangent t all over 1 minus tangent s times tangent t. Okay. So let's see. Common denominator is 24 here. So 3 over 3 times 15 over 8. That's 45 over 24 plus, now 8 times 4 is 32 over 24. Okay. Divided by 4 here. Okay, 15 divided by 3. So 1 minus 5/2. So 2 over 2 minus 5/2 is minus 3 over 2. All right, 45 plus 32. That's 77 over 24. Now times minus 2/3. So 24 divided by 2 So that's minus 77 over 36. Okay, so tangent of s plus t is equal to minus 77 over 36. All right, now, what is the quadrant of s plus t? Well, we've got tangent of s plus t and sine of s plus t, and we see that the sine is positive and the tangent is negative. So with that, let's think about where is sine positive? Well, that's in the first and second quadrants. Okay, now where is tangent negative? That's in the second and fourth quadrant, so it matches up in the second. So the answer to part C is the second quadrant. Okay, so we've got sine of s and sine of t, so let's find cosine of s and cosine of t. So sine squared s plus cosine squared s is equal to 1. So sine of s squared is going to be 4/9. All right, so cosine squared s, 9 over 9 minus 4 over 9 is 5 over 9. So cosine of s is equal to plus or minus root 5 over 3. Now, s is in quadrant 2, and we know that cosine in quadrant 2, so x over the hypotenuse, x is negative. So cosine of s is negative root 5 over 3. So, okay. Okay, now sine squared of t, Pythagorean identity, plus cosine squared of t is equal to 1. Sine of t squared would be 1/9. Minus 1/3 squared is 1/9. Plus cosine squared of t is equal to, so 1 is 9 over 9. So 9 over 9 minus 1 over 9 is 8 over 9. Okay. So square root of 8 is 2 root 2. Square root of 9 is 3. Okay, t is in quadrant 4, and cosine the x side is positive in quadrant 4, so cosine of t is positive 2 root 2 over 3. Okay, now tangent of s using the quotient identity, we can write that as sine of s over cosine of s. So that's going to be 2/3 times the reciprocal of cosine, so minus 3 over root 5. That's minus 2 over root 5. Multiply that times root 5 over root 5, and you've got minus 2 root 5 over 5. So tangent of s is minus 2 root 5 over 5. Okay, now tangent of t is, using the quotient identity again, sine of t over cosine of t. So sine of t minus 1/3 times the reciprocal of cosine t, 3 over 2 root 2. So minus 1 over 2 root 2. Multiply this by root 2 over root 2. And you get 2 root 2 times root 2 would be 4. So minus root 2 over 4. So tangent of t is minus root 2 over 4. Okay. So now sine of s plus t is equal to sine of s 2/3 times cosine of t 2 root 2 over 3 plus cosine of s minus root 5 over 3 times sine of t minus 1/3. Is that right? Sine of s 2/3 times cosine of t 2 root 2 over 3 plus cosine of s times sine of t. Yeah. So we've got, let's see, 4 root 2 over 9, and then plus root 5 over 9. So sine of s plus t is equal to 4 root 2 plus root 5 over 9. All right, now tangent of s plus t is equal to, using the sum identity for tangent, so tangent of s minus 2 root 5 over 5 plus tangent of t, so that's going to be minus root 2 over 4 over 1 minus tangent of s times tangent of t. So tangent of s times tangent of t is going to be positive, so the minus just stays. And then you've got 2 root 5 over 5 times root 2 over 4. Okay. So we can create a common denominator up here. Let's take this out. So multiplying this first fraction by 4 over 4, you get 8 root 5 minus 8 root 5 over 20 minus, and then multiplying this by 5 over 5, 5 root 2 over 20. And then here we've got 1 minus root 10 over 10. Okay, so let's see. Minus 8 root 5 minus 5 root 2 over 20. And then we can change this 1 to 10 over 10. So that gives 10 minus root 10 over 10. Okay, so let's see. We've got minus 8 root 5 minus 5 root 2 over 20. And then times, let's see, 10 minus root 10. Okay, so this is 2. So we've got minus 8 root 5 minus 5 root 2 over, and that would be 20 minus 2 root 10. Okay, now let's multiply this by 20 plus 2 root 10 over 20 plus 2 root 10. So in the numerator, we've got 20 times minus 8 is minus 160 root 5. minus 16 root 50 minus 100 root 2 minus 10 root 20. Okay, all that over 20 times 20 is 400. And then that would be 400 minus 4. So 2 root 10 times 2 root 10 would be 4 times 10. So 400 minus 40, which is 360. Okay, so 50 is 25 times 2. So let's see. So, okay, root 50, 25 times 2, we could write that as 5 root 2. All right. 20 is 5 times 4, so we can write that as 2 root 5. All right. So we've got minus 160 root 5. Okay, 16 times 5 is 80, so minus 80 root 2 minus 100 root 2, and then minus 20 root 5 all over 360. All right. Now, minus 160 minus 20 is minus 180. And then minus 80 minus 100 is minus 180. Let's see, is that right? Minus 160 minus 20 is 180 minus 8. Yeah. Okay. Now, factoring out a 180, you've got minus root 5 minus root 2. And then, so we can see that tangent of s plus t is minus root 5 minus root 2 over 2. Okay. Now the quadrant of s and t. So let's see. Sine is positive. Tangent is negative. Tangent is negative in quadrants 2 and quadrants 4. Sine is positive in quadrants 1 and quadrants 2. So the answer is quadrant 2.